Well, today I created myself a bit of an emergency here by taking old electronics for granted. I basically created a real high pressure job because I promised something before checking it out, only to find out that it wasn't working. Talk about working under pressure. I really don't enjoy working under pressure. Deadlines, I don't like deadlines. And unfortunately, I opened myself up to a deadline which I wish I didn't have to open myself up to. But the other day I got a message from my buddy that I've known since I was about 12 years old. And it was not the kind of message I was expecting to receive from him. It's the type of message that, nobody wants to receive. But it went, and I'm kind of paraphrasing because I don't have it on my phone right now. But it went something along the lines of, I lost my son yesterday due to some medical event, and he was only 29. So, of course, that throws his world into a turmoil because you're not supposed to lose your kids at the age of 29. I can understand if there was an accident or something, but this was a medical condition that just came out of nowhere. The man was very fit, and he was an actor in movies and TV shows. And anyway, today I get a call from him, and he's got all these home videos of his kids, and he's trying to put together a memorial. And stupid me, I said, "Oh, gee, I just fixed my little 8mm camera. You can have this to play your tapes back on." He's trying to make a compilation tape. He's got all his tapes to go through. So I told him, "Yeah, no problem. I've got this one. You can use this camera. Come on over and get it." And I figured maybe I better try it and make sure it works. And when I plugged in the power supply, it's dead. So now the pressure's on because the camera works. I know that. I can power it up with my power supply and it works fine, but this is dead. So now the pressure's on to fix this thing, and he's kind of on his way over to pick it up because unfortunately he lives a while away, and he's not in a very good condition to drive today, so I may have a few hours before he shows up to pick it up. But say now the pressure's on because I've told him, yeah, you can borrow my camera, and my camera the camera works but the power supply doesn't. So let's crack this thing open and see if I can get it to work. Now Sony usually put an extra screw in under the sticker to try and keep people from opening these things up. So let's just peel the sticker back. And back in the day, these were considered a non-serviceable item. If the power supply broke down, you bought a new one. Okay, they didn't do it on this one. They made a liar out of me. See, I got lots of power supplies for the newer cameras, but not for this older one. This one runs on 6 volts, whereas most of the new ones run on 7.2 or 8.4. This one's a 6 volt adapter. Actually, it's output 7.5 for the VTR and 10 volts to charge the battery, but it used a 6 volt battery. It was one of the ones that used the nickel cadmium batteries. Okay, we'll just pop apart. I have a sneaky suspicion there's another tab that holds this shut somewhere. Maybe not. It's been a while since I've opened one of these up. There we go. Some of them had a screw underneath here. Not this one. Okay, let's see why this thing doesn't work. It's of course a switching power supply, so I'm gonna guess that there's a cap that's gone bad on this thing. And since I just had it plugged in, there's a pretty darn good chance that this capacitor is going to be fully charged, because if the oscillator doesn't start, then the main filter is going to be charged. Let's remove these screws here. It's funny because this adapter did work when I fixed the camera. What was it? Not even a month ago, I think. When I worked on the camera, the adapter worked fine then because I used it, but it's not working now. And of course, one screw is going to not cooperate. Oh, what do we have here? It looks like moisture. I'm going to guess it's capacitor juice that's leaked out onto the board. Probably because it hadn't been used in a while, and when I plugged it in there a month or so ago to operate it, the capacitor decided to take a piss all over the board. Oh, yummy. That's exactly what's happened. That's exactly what's happened. This big cap right here, which we'll make sure is dead, has pissed on the board. Oh boy. What other damage has been done? This is the filter, the main primary filters over here. We'll make sure that this is dead. So it might just be this area over here. There's corrosion on the board here. Let's clean this off. We'll get some cleaner and spray that off and get that crap off the board first. I'm just using MG Chemicals HFE electronics cleaner, just to wash this stuff off the board. I don't know what the damage is on this right now. Definitely this cap is the one that leaked. 1200 microfarad, 16 volt it looks like. You might wonder why I'm applying more solder on here. I'm just trying to get the heat to transfer in to the original part. So getting some molten solder on there will sometimes speed the process of getting the heat to transfer down so that I can actually remove it, because it's all oxidized from the leaking electrolytic. Yep, that's the one that blew up right there. Yummy, huh? I don't know whether that's the only problem on this thing. It probably is not. It's probably caused other damage. We'll just clean this crap out of here. Now I may have got lucky. This may be the only part that's actually blown is this one. Could always hope. 1200 at 16 volts. I'm not going to have one. I don't think I'm going to have one that side, but I should have one that's close enough. I have a 1000 at 25, which is as close as I've got. So we'll try that one. Polarity wise, it's positive to the left, I think. Yeah, the dot's on the right here, so this is the positive on this side. You can see the dot right down there for the negative terminal. So I'm going to put this in. This one's probably going to be a little too tall to put the cover on. So I may have to just bend this thing over and kind of tuck it down in behind here. I think I'm going to have to do that. I'm going to have to tuck it in, bend it down, and tuck it in here. Either tuck it in here or tuck it in somewhere, maybe down like this. It's not ideal, but it's not a heck of a lot. I don't have a lot of options because this other one was a low profile. So we'll see whether that will work. C106 here is our main AC filter on the primary side. So let's see when I apply power whether this thing's going to charge up. This should charge up to about 170 volts or so. And it is 172 volts. So that part's working. Let's see how fast it discharges. Looks like it's going down pretty quick, so that's a good indicator that the oscillator is probably working, which is good. See, it's discharging relatively quickly. There it goes. So there's a good chance the oscillator's working. Let's see if we get any DC voltage on the DC side, which is over here, the cap that I just replaced. So we'll try it again, we'll power it up, and we'll just look at the voltage across the new cap that I just put in, and it's 0. So there's no power there whatsoever. Now these diodes here were caked in crap, so maybe we've got an open connection around here on the diodes. Let's check the diodes first of all and see if they're shorted. These diodes will be relatively low forward dropping voltage across them because they are switching diodes, so let's see. That looks to be good there. That looks to be good there. How about in the reverse direction? Yeah, look okay. Okay, I'm just going to inspect the traces here and see if any of these traces are eaten away. That's my first guess, is that the corrosive electrolytic has eaten away some of the traces. So let me get a close look at this and see. So if we look down closely at the board here, we'll see that the transformer, the secondary of the transformer, goes into the two outside pins on the diode here, and then the common connects over here to my capacitor. So let's check to see first of all that we have continuity between the transformer and the diodes. So we'll check across here, and we do have continuity there. And we'll check continuity between the center of the diode and the capacitor, and we do have continuity there. So if the oscillator is actually working, I would expect to see a voltage across here, but I'm not seeing any voltage applied across the capacitor. So the oscillator must not be working, or the transformer is damaged. But I'm going to guess that it's probably the oscillator is not working. And the reason that the voltage is dropping off on the main filter is because there's going to be a bleeder resistor across it. Now the oscillator typically gets started by a small cap over on the primary side that gives it a kick. The chopper transistor is over here to also make sure that this isn't bad. So I've already discharged this, so there's no chance of getting a shock. But I'm just going to take a look at the circuitry over here as well and see if there's any other damage from leakage, because this leaked across here. Across the chopper transistor there's a Zener diode, and I was just doing some measuring and I found a short over here, so I've just disconnected one side of the Zener diode, and the short emitter base is gone. And we'll measure the Zener. That Zener diode is shorted. So let's remove it and see what value this Zener diode is. And fingers crossed I'm going to be able to come up with one pretty quick, because stores have all closed today. They're not open tomorrow. And if I don't get this thing going today, there's going to be a bit of a problem. So here's the Zener out of the unit itself. Shorted. Let's see what size this thing is. The number on the diode is a 2075, so that would be a 1N2075, and that's not a Zener. That's just a high-speed switching diode, even though the stencil on the board indicates it's a Zener. So I'm going to put a high-speed switcher in, and we'll see if this thing starts up. I don't have a schematic for this, so I can't confirm that, for the power supply, but getting the number off the part itself, I think we're probably okay. It's either going to work or it's going to go boom, one of the two, so we'll find out pretty quick here. I'm so confident in my work that I'm actually going to kind of assemble this thing a bit before I try it out. Probably a mistake, but since I got to plug it into the top half of the unit to make a connection, because there's plugs on here that have to be inserted, so I just want to make sure that it's not going to short out against anything when I plug it in. So I'm just going to kind of stick it sort of together, and then we'll test it and see whether it works. See, this is from back in the day when they actually used to shield equipment because they were concerned that the power supplies could possibly cause interference to radio. Really? Who would have thought that a switching power supply isn't going to cause any interference to a radio? Okay, let's get this thing back together and then we'll power it up and see what happens. The moment of truth. Power! Yes, okay. I think I got it going. I think one of the reasons it didn't power up before when I tried it, when I was measuring voltage with the unit apart, was because this switch here is part of that board on the top, so it has to be plugged in to the unit itself and kind of put together. So I'm going to put the screws back in it now. We'll make sure it powers up the camera, and now the pressure is not quite as high as it was a few minutes ago when I started on this thing, so that I can loan this camera out so that my buddy can make some copies of his tapes, edit some of his tapes for his son's memorial. Just going to make sure the camera's playing properly before I loan it out. And there it is. Camera works, so I'm happy now. This thing's working good enough anyway. This is an old tape that I shot of someone's wedding. This is my B-roll. I showed this tape before when I fixed the camera, but now we know the camera's working, the power supply's working, And that's something to keep in mind when you have an old power supply. It hasn't been used for a while. You plug it in and it works. And you let it sit for a couple of weeks or a month or so, and you go to use it again and it doesn't work. You open it up and find the caps have all pissed all over the board. So what happened in this case was, I guess from sitting, the seals had failed in this Rubicon original cap. And when I powered it up the first time there, it basically built up pressure and emptied the contents of the electrolytic onto the board. And took out a Zener diode in the process because of the contamination on the board. So that's it. That's the repair of a Sony AC adapter AC-V35. This same exact adapter was also marketed as the AC-V65. The difference between the two of them, they were identical except for the V65 had the it had the audio video outputs on the back side here. Some of the cameras came with that power supply. Identical inside. If you have one of these power supplies, it's not working. That and whatever else has gone wrong in there. But I would advise, if you're planning on using one of these things and it's been sitting around for a while, before you plug it in, change that cap, because otherwise you're going to create yourself a big headache like I just did today. So even though it shows as a Zener diode on the circuit board there, the actual diode that came out was a 1N2075, and that crossed to a NTE 117, which is just a high-speed switching diode. I don't know why, why they had it marked on the board as a Zener. I don't have a schematic for the power supply, but it's just a standard switching diode that was in there, and I guess it's just for protection. But anyway, I just put a regular switching diode in place of it. It's fired up. Just a general purpose silicon was all I put in place of it. And it's working, so there we go. We'll catch you in the next one real soon. Bye for now.